All right. So 13.5 is adding and subtracting polynomials. So we will be able to do this by what we call like terms. So your like terms are terms that you can add and subtract from each other with no problem. So what allows us to do that are the fact that we have the same variables, same amount of variables, same exponent of your variables. If we have that, then we have like terms. So where's my pen? Oh, there we go. Sorry about that. So this left column are like terms. And too dark. Yes. So we see 3x and 5x are like terms. 8x squared, negative 10x squared, like terms. Negative 121 x squared y, and then 70x squared y. And then even having numbers that have no variables at all, just our regular numbers that we deal with, are considered like terms. All right, so if anything's different, then they're unlike terms and you're not able to add them together or subtract them from each other. So in this right column, oh, my pen is too dark. I had to make an adjustment one class. There we go. So on this right column, just example of unlike terms. So 3x and 5, one has x, the other one doesn't. So to consider unlike, you will not be able to add them to each other. Here, 8x squared, negative 10x, one has the power of 2, the other one doesn't. So you cannot add them or subtract them from each other. And then this last one, even though both of them have x and y, one has the power of 2 and the other one doesn't. All right. Once again, if they are not like terms, you cannot add them or subtract them from each other. All right, scroll up. I guess I can leave that. So here, just different variations of 5x and 3x, different scenarios you could come across. 5x, whoa. 5x plus 3x, they are like terms. They both have the variable x. So you just add the 5 and the 3, and that'll give you 8x. 5x plus 3, since one has x and the other one doesn't, you cannot add them together. So that's considered being in lowest terms already. 5x plus 3y, one has x, the other one has y. Cannot add them together, so that's already in lowest terms. 5x squared plus 3x squared is 8x squared. They both have the power of 2, they both have x, so you can add them together. And then 5x squared plus 3x, cannot add those two together, so that's already in lowest terms. All right. Questions on that before we look to add and subtract our polynomials? All right. So first one, we have 10x minus 2y plus 7x plus 5y. And you want to simplify the expression. So you want to add your like terms. So we add the 10x to the 7x, which would be 17x. And then negative 2y plus 5y would be plus 3y. All right, any problem with that? All right, next one, we have negative 3c cubed plus 5c squared minus 7c plus 11c cubed plus 6c squared plus 3. Once again, combine your like terms. So you see 3c cubed and 11c cubed. That's a negative 3, so that'll be 8c cubed. Then 5c squared plus 6c squared, 11c squared. So I don't have another c term. I just bring that down. Don't have another constant term. In other words, a term that doesn't have a variable. So I just bring that down as well. Any problems? All right, 4w squared minus 2x plus 3w squared minus 4x squared plus 6x. So we see 4w squared and 3w squared. That's going to be 7w squared. Then we have negative 2x and 6x. That will be positive 4x. And then I can't combine that 4x squared with anything. So I just bring that down. Don't forget to keep your signs. That was a negative 4x squared, so I brought down the negative 4x squared. Any problems? All right, so when it comes to subtraction, you're going to do the same thing, except, oh, got my eraser still on. You have to give an account for this minus sign right here. And that minus sign has to be distributed to each term in the parentheses that follows. So the result of that is that the first set of terms will stay the same. And then the minus sign will change the sign of each one of the ones that follow. So it'll be a negative 11p squared minus 4p plus 6. All right, any questions? All right, so now you want to combine your like terms if possible. So there's nothing that can combine with this negative p to the fourth, so you can bring that down. And we see that we have 5p squared, negative 11p squared. So it's negative 6p squared. Then there's nothing that can combine with this 4p, so you bring that down. And then we have negative 3 and a positive 6, which is positive 3. Any questions? All right. Next one, a squared minus 2ab plus 7b squared minus negative 8a squared minus 6ab plus 2b squared. So just like before, we're going to distribute the negative into the parentheses that follows. So if I had to rewrite this, that would be a squared minus 2ab plus 7b squared. And then we're going to change the signs of each one of these terms. So that's a positive 8a squared plus 6ab minus 2b squared. Now we combine the like terms in each case. So a squared plus 8 squared is 9a squared. Negative 2ab plus 6b is plus 4ab. 7b squared minus 2b squared would be plus 5b squared. All right, questions? Any questions? All right, anything, anybody? Is everybody okay? All right. Got multiplication of polynomials. Let's see, how long is this section? Well, we can do this, right? It's not gonna take that long. Let's knock this out. Erase some of this stuff. All right, so let's look at multiplication of polynomials, another short section. If we have 3x to the fourth times 4x to the second power, so we're going to multiply the coefficients that's the numbers that are in front. So that's 3 times 4. Then we'll multiply the variables. So that's x to the fourth times x squared. Three times 4 is 12. And then don't forget, you're going to add the exponents. Add better. So you're going to add those exponents. That'll be x to the 6. All right. Same thing down here. We have negative 5c to the 5th d, 2c squared d cubed e. And so we want to, once again, and whether you write this out or not, this is how you should be processing what's going on. You know, you're going to multiply negative 5 times negative 5 times 2, excuse me. Then c to the 5th times c squared, d times d cubed, and then e wouldn't be multiplied to anything. Put it like this, you can't multiply anything to simplify it, but it's still multiplied to your expression, of course. So negative 5 times 2 is negative 10. Don't forget we're adding our exponents, so that's c to the 7th. Here, d. If you don't see anything there, so you know there's a 1 there. So adding your exponents would be d to the 4th, and then e would be the last part of your answer. Any questions? So when you're multiplying, you multiply the numbers in front, and then your variables, you add your exponents. For your like variables, you add your exponents. All right, so for this next one, if we have a minus sign or a plus sign in between terms, you're going to distribute. So that's going to be 2t times the 4t, and then 2t times the 3. So once again, this is how you would be processing what's going on. You don't necessarily have to write that out, especially once you get more comfortable with the process. If you are that way already, you know, you wouldn't have to write it out once you get more comfortable. You just go ahead and write out what it is. So 2t times 4t is going to be 8t squared. 2 times 4 is 8. T times t is t squared. And then 2t times 3 is 6t. All right. So this one we have negative 3a squared times negative 4a squared plus 2a times negative 1/3. So you have to distribute negative 3a squared to each term. All right. So first one, negative 3a squared times negative 4a squared. Negative 3 times negative 4 is a positive 12. A squared times a squared, you're going to add those exponents. So it's a to the 4th. Then you have negative 3a squared times 2a. Negative 3 times 2 is negative 6. A squared times a is going to be a cubed. And then negative 3a squared times negative 1/3. So here, just emphasize the fraction process. Negative 3 times 1/3, that should be 3/3, which will give you 1. So that will be 1a squared. And over here, I was emphasizing that 1a and a are the same thing. They're going to assume you know that. You know that if you don't see anything in front of a variable, they assume you know there's a 1 there. All right, any questions? Any questions? All right, so the next one, if we have two binomials, c minus 7 times c minus 2, so you can either lean on the FOIL method, first, outer, inner, last, or just remember that each term in your first parentheses has to be distributed to each term in the second parentheses. All right, so that's going to be c times c, which is c squared, c times negative 2, which is negative 2c, negative 7 times c, which is negative 7c, and then negative 7 times negative 2 is positive 14. All right, now we have like terms in the middle. So we can finish that off as c squared minus 9c plus 14. Questions? Any questions? All right, next one. Let me do this. Erase this first. All right, so we have y minus 2 times 3y squared plus y minus 5. So just like we handled this one right here, c minus 7 times c minus 2, you distribute each term from the first into each term of the last. We handle this last one the same way. Distribute the y into each term, and then we'll distribute the negative 2 into each term. I said the last one, I didn't mean the last one, but this one right here. Y times 3y squared is 3y cubed. Y times y is y squared. Y times negative 5 is negative 5y. Then distribute negative 2, so it'll be negative 2 times 3y squared, which is negative 6y squared. Negative 2 times y, negative 2y. Negative 2 times negative 5 is positive 10. any problems. Combine your like terms. You have y squared, negative 6y, 5y, and 2y. Both of them are negative. So that's going to be 3y squared, 3y cubed. 5y, that's going to be negative 5y squared, negative 7y, plus 10. Any questions? All right, make sure we're okay before we look at this last type of problem. See, we got one more after this, same thing. Just check to see what we got left. Okay, that's the last type of problem. Okay, all right. So here we have what we call difference of squares. We'll see more of this and emphasize it more when we actually get into factoring in our last chapter. But here, whenever you have the same two terms, but the only difference is the middle sign. One is negative, one is positive. Something should cancel out for us. Our middle term should cancel out. Same thing here. Our middle term should cancel out. So when we do our distribution, x squared plus 9x minus 9x plus minus 81. Nine x's will cancel in the middle. That would be x squared minus 81. All right. Same thing here, 1/2 p times 1/2 p. It's going to be 1/4 p squared. And that's what I have right here. 1/2 times 1/2 is 1/4. 1/2 times negative 6. That ends up giving us 3. So half of 6 is 3. So that's negative 3p. 6 times 1/2, positive 3p. And then 6 times negative 6 is negative 36. All right, 3 p's cancel in the middle. That gives us a final answer of 1/4 p squared minus 36. All right. Questions? Any questions before we look at this last type? All right, so this last one is when we have a square sitting out here. Whenever you have a square, what you cannot do is square each one of these and do it right. what you actually have to do is expand it out this way. So notice we have 3w minus 4 times 3w minus 4. So that whole expression is what's being squared, not just 3w or not just the 4. So once you recognize that, you have both expressions. And then you go ahead and do your binomial distribution. Distribute 3w. So 3w times 3w is 9w squared. 3w times negative 4 is negative 12w. Negative 4 times 3w is negative 12w. Negative 4 times negative 4 is positive 16. And from there, combine your like terms. Negative 12 is negative 24. There's your final answer. Well, that's your middle. But your whole answer is 9w squared minus 12w, 24w plus 16. All right, one more. Here we have 5x squared plus 2 squared. So once again, we're looking at 5x squared plus 2 times 5x squared plus 2. So you have to multiply 5x squared plus 2 to itself twice. So just like if it was a cube out there, then you would have wrote it 3 different times. Don't believe you guys will see a cube, but just, putting it out there, you have to repeat the multiplication twice because we have the exponent of 2 applied to the expression of 5x squared plus 2. So from there, you go ahead and distribute 5x squared, then distribute 2 into the next set of parentheses. 5x squared times 5x squared is 25x to the 4th. 5x squared plus 2 is 10x squared. 2 times 5x squared is 10x squared, and then 2 times 2 is 4. Finish it off by combining your like terms in the middle. And that'll be 25x to the 4th plus 20x squared plus 4. All right. Questions? Any questions? Any questions? All right, so that's it for today. Next class, we'll look at the last section in chapter 13, which is division of polynomials. And then we'll go from there. Don't forget to stay up on your work. Make sure you're knocking out the stuff in Connect Math. And then we'll talk about how we're going to assess chapter 13's test. Questions or concerns before we close out today? All right. Well, you guys have a good one. Be safe. Have a great weekend. And I will see you on Monday.